operations in polar form. The main idea is that if we take two complex numbers which are written in polar form and multiply them together, the modulus of each of them will multiply and the arguments will add. Okay, so let's look at an example. So here we have z given as root 3 plus I and w as 1 plus root 3i. So let's convert them to polar form. So the modulus of z is the square root of 3 plus 1, which is 2, and the modulus of w is square root of 1 plus 3, which is also 2. We calculate the argument so the argument of z is arctan of 1 over root 3, and to calculate this I'm going to use my triangle 1 to root 3, pi on 3, pi on 6. Now we have opposite over adjacent, so opposite over adjacent, the argument is pi on 6, and for w the argument is arctan of root 3 over 1, which is arctan of root 3. Since tan is opposite over adjacent again, we see the argument here is pi on 3. Okay, so putting this together, we see that z is 2e to the I pi on 6, and w is 2e to the I pi on 3. Okay, so what the next part of the question says, evaluate z times w, so in polar form. So z times w, we just multiply the modulus of each, so we get 4, and then we'll have e to the I pi on 6 plus pi on 3. So we add the arguments. Okay, so what do we get when we add these arguments? We're going to have pi on 6 plus 2 pi on 6, and this is 4e to the I 3 pi on 6, which is 4e to the I pi on 2. This is the same, although, so if we wanted to write this in polar form, this would be it. If we wanted it in Cartesian form, then we could just write this as 4i. Okay, so the next question is to find z over w. So let's do this one in red. So z over w is given by 2e to the I pi on 6 divided by 2e to the I pi on 3. The modulus here of each will divide, so 2 divided by 2 is 1, and the arguments will subtract. So you get pi on 6 minus pi on 3, which is e to the I pi on 6 minus 2 pi on 6, and this is just e to the minus I of pi on 6. Final question is to look at 1 over z. Let's put this in green. So what we'll have is 1 over 2 e to the I pi on 6, which is just 1/2 e to the minus I pi on 6. And that's it for that. Okay, let's look at another example. So here we have evaluate 1 plus I to the 12. So this is the real power of polar form. So we'll write 1 plus I in polar form. So we'll have the modulus being the square root of 1 plus 1, which is the square root of 2. And the argument is arctan of 1 over 1, which is pi on 4. So what we see is that 1 plus I to the 12 is the same as square root of 2 e to the I pi on 4 to the 12. Now square root of 2 to the 12 by index laws is just 2 to the power of 6, and then I'll have e to the 12 pi on 4, which is 2 to the 6 e to the I 3 pi. Now if I wanted it in polar form, that would be enough. If I wanted principal argument, so the principal argument is between minus pi and pi, then what I would do is write this as e to the I pi, just subtracting 2 pi, multiples of 2 pi. So we can have this as the polar form. If we want to write this in Cartesian form, then this is just 2 to the 6 cos pi plus I sine pi, and cos pi is just minus 1, so we get minus 2 to the 6, and sine pi is 0, so this is just negative 2 to the power of 6. Okay, as our final example, let's solve z cubed equals 1 minus root 3i. So again, we're going to write this right hand side in polar form. So 1 minus root 3i is going to have a modulus of 2. So it's 2 e to the I theta, and theta is given by arctan of minus root 3 over 1. Again, we have our triangle to figure out this exact value. And what we'll have is opposite over adjacent, so it's some multiple of pi on 3. Since we have a positive real part and a negative imaginary part, we lie here. So theta is minus pi on 3. So in particular we get 2 e to the minus I pi on 3. Okay, so that's what z cubed is. Okay, so now we're going to use, I believe this is what deMoivre's theorem is. So we're going to take the cube root, so we'll get 2 to the 1/3, and then e, or minus, let's not put the minus there for the moment. So we've got I, then minus pi on 9 plus 2k pi divided by 3 because of the cube root. And now we're just going to cycle through values of k. So if we take k equals 0, then what we get is 2 to the 1/3 e to the minus I pi on 9. If we take k equals 1, we get 2 to the 1/3 e to the I minus pi on 9 plus 2 pi on 3. This is the same as 2 to the 1/3 e to the I. We can write this as 6 pi over 9. So what I'll end up with is 5 pi over 9. And in the final case, we get k equals 2. So z is 2 to the 1/3 e to the I minus pi on 9 plus, if I put 2 in here, I get 4 pi on 3. And this is the same as 2 to the 1/3 e to the I minus pi on 9 plus 12 pi on 9. So the final answer will be 11 pi on 9. And that's it. Since practicing is so important, be sure to check the video description for the tutorial notes. The answers for those questions are found in the cheat notes. If you like the video, hit the like button, and please subscribe if you found this content useful. Thanks guys, I'll see you in the next video.